Good morning, my YouTube viewers. It's Crystal here. This is the final video that I'm going to make in Explore Statistics with R. And what we're going to do is we're going to do a case study of ethics in statistics. So our case study is a manufacturing company tests a new cleaning process to reduce contamination levels. A technician removed several bad observations before analysis, claiming they were obvious outliers. The company wants to know, did the new cleaning process actually reduce contamination, or did the selective data removal create a misleading result? So our null hypothesis is going to be no significant difference, and our alternate hypothesis is going to be a significant difference. So we're going to simulate this case study in R so you can see how it's done. So the first thing we're going to do is we're going to set the seed. The reason why you set the seed is so every time you run the program, the variables will initialize to the same value. So you type set.seed brackets 1, 2, 3, and then you can type any number that you want within the brackets. So basically now we're going to do is we're going to set up our true contamination levels, and so the lower the level the better. So the old process is a mean of 12 and a standard deviation of 3, and the new process is a mean of 10 with a standard deviation of 3. N equals 40, so that is the number of samples. So the old is a randomly sampled normal distribution of 40 samples with a mean of 12 and a standard deviation of 3, and the new process is a randomly sampled normal distribution with a mean of 10 and a standard deviation of 3. And then so your group is a repetition vector with a vector inside of it with old and new, and each is 40. So you're going to have 40 olds and 40 news. And so contam true is a vector that contains old and new. So we're going to create a data frame with this information, and we're going to say data true is data.frame brackets group with contam true in it. Let's see what your group is. And your group is the old and the new. And so now we're going to take the unethical removal. We're going to delete the top 5 bad values from the new process. So new sorted becomes sort brackets new. And new unethical becomes new sorted square brackets 36 to 40. So that means you're going to remove the 5 highest samples. So we're going to create a data frame of the unethical data, becomes data.frame, and group is a vector, a repetition vector of old 40 times and new 40 times minus 5. So new is going to be 35. Contam is going to be a vector of old and new unethical. So what's interesting here is the fact that you have 40 old and 35 new. So we'll see how that's going to affect the program. So we're going to create box plots. So PAR brackets MF row is a vector of 1 and 2. And then we're going to create a box plot. box plot brackets contam true tilde group, and data equals data true. Main, which is your title, is ethical data. Color is a vector that has tomato and sky blue in it. And then we're going to create a second box plot. So box plot brackets contam tilde group, comma, data equals unethical. Main equals unethical data selective removal, that's your title. Color is a vector of tomato and sky blue. So now what we're going to do is we're going to do the ethical t-test. So ethical result becomes t-test brackets contam true tilde group, data equals data true, and unethical test is unethical result becomes t dot test brackets contam tilde group, comma, data equals data unethical. So we're going to print the results of, we're going to print ethical results, and then we're going to print the unethical result. So we're going to come down here and see what we've got here. So we've got that for the ethical result, you've got your p-value of 0.0008856. So that tells you right there that that it is below the significance level of 0.05. So that's telling you that there is a significant difference between the means and the groups in the ethical. And then so you've got your alternate hypothesis is the true difference in means between group new and group old is not equal to 0. And then you've got your confidence interval being neg 3.39 to neg 0.914, and you've got your sample estimates. So the mean of the new group is 9.97, and the mean of the old group is 12.1. But let's just come back here. Yeah, it says the mean of the old group is 12 and the mean of the new group is 10. So that's very close to the means that we have identified. But it's still below the significance level, so you still would have to go with the alternate hypothesis. Now we're going to have the unethical result. So you've got your T is neg 5.0196. Degree of freedom is 72.882. And the reason why that is because you don't have as many elements in the so you're going to have 40 plus 35 is 75 minus 2, so it's going to be 73, so you've got 72.882, but your degree of freedom for the ethical is 40 plus 40 is 80 minus 2, so it would be 78. So the degree of freedom for the ethical is very close. You've got a p-value, which is a very low level. It's much lower than the level of the ethical group, but so it's definitely below the significance level of 0.05. So you would have to go with the alternate hypothesis in both the ethical test and the unethical test, because both of the p-values are less than 0.05. But you've got your 95% confidence interval is neg 4 to 0.01 to neg 1.73. So you can see that the confidence interval is different in the ethical test than it is in the unethical test. And then so the mean in the new group is 9.26, and the mean in the old group is 12.13. So the mean in the unethical result for the new group is less than the mean in the ethical result for the new group, and the mean in the old group is very similar, very close to the same. So these are the box plots that we have created. So you've got your one box plot for your ethical data and one box plot for the unethical data. So you can see that there is a slight difference between the ethical data and the unethical data, and the main difference is being that there's more of a significant difference between the unethical data than the ethical data, but both ethical and non-ethical, you're going to have to go with the alternate hypothesis, because there is a difference between the means in these two groups. So what we're going to do now is we're going to come over here and we're going to interpret it. So we're going to interpret the selective removal bias results. It violates the principles of transparency, reproducibility, and honesty. It can lead to incorrect decisions, such as approving a process that doesn't actually work. So ethical statistics requires, 1, you have to predefine outlier rules. 2, you have to have full documentation. 3, you have to report all data unless removal is justified. And 4 is you have sensitivity analysis. And so you can see that there was a difference in the test results in the ethical analysis and the unethical analysis. And so you're always going to want to try to go with the ethical analysis. If you do remove any samples, you have to justify why you're removing those samples, which wasn't done in this test. So this was just a case study on how ethics is important when performing statistics, because if you don't adhere to ethical practices, then what's going to happen is you can give misleading results, and you don't want to give misleading results. And so this is the final video in this little course that I've made called Explore Statistics with R. This is the last video. I hope that you got something out of this video, and I hope that you got something out of all the videos that I've made. And I look forward to communicating with you in the next course that I decide to make.